Welcome to another video where we're going to take a look at the Model Mania Design Challenge from SOLIDWORKS World 2002. If you're unfamiliar with Model Mania, it's a design challenge held every year at SOLIDWORKS World where you're given a drawing similar to this and you're tasked with creating this part in SOLIDWORKS both as fast and as accurately as possible. And if that wasn't challenging enough, once you're done with this part, you're given a second drawing where you have to make a variety of changes to the part. Now we're going to hold off on looking at the second drawing until we get to that point because there's some surprises there. But let's go ahead and look at how we might tackle this. One of the first things you'll notice is that this part is symmetrical, both about section AA as shown in the top view, so from left to right, but also from top to bottom as we can see both in the section view itself and the front view. Now, also unique is the direction of the two holes in this part. The main 70mm bore in this part appears in the front or right-hand side view, where the other bore of this part comes down from the top, and yet we have to capture that relationship. So let's go into SOLIDWORKS and look at how we'll tackle this. The first thing I want to do is start by capturing most of that profile, keeping in mind that this is a mirrored part or a symmetric part. I'm going to start on my right plane and I'm going to start with one of the easiest features, this big 70mm diameter circle. And while I'm at it, I'm going to go ahead and capture that 7mm offset right now as well. The next thing I know is there is a line that comes off from this circle that's tangent. If you drag a line out from a circle while maintaining tangency, you'll notice that that line will preserve that. I'm going to go ahead and just drop this out here, and then we'll go ahead and kind of draw the rest of this profile. I'm going to kind of snap out here and out here. Now, you've seen, if you've watched the previous videos, I like to use contour selection, and we'll go ahead and do that again here. I'm going to go ahead and just trim these arcs. Now I could go ahead and remove all of that just like so as well. But keep in mind, you could have left this. There's no reason you have to trim this. Now the next thing I need to do is I need to capture this angle. That's 15mm. Let's drag this in because I know that that's pretty long. So we'll set that to 15. And now we have to determine where the end of this is. Now the end of this is, if we go back to the drawing, is determined by the diameter of the bore in the top, but also the 7mm offset to the outside. So if we come back, how do we capture that? Well, there's a variety of ways you could do this. You could do this doing some math. So for example, you could put a construction line in here, and you could say, well, it's 100mm out to the center of this circle. And then you know that, well, from here to here, it's going to be half the diameter. So we could type in 15 divided by 2 plus 7mm, and we could get it that way. But what happens if the diameter of the circle changes or the offset? You'll have to go back in here and recalculate all of that. So this isn't a very efficient way of doing this. So let's go ahead and delete this geometry and think of another way. Even though the circle is drawn from the top view, there's no reason we can't use a circle and capture this information here in an earlier sketch. So what I'm going to do is I'm going to do just that. I'm going to dimension that 15mm diameter circle 100mm off from the primary bore. And then what I'm going to do is I'm going to dimension from the end of the part, and while holding the shift key, snap to the tangency of that circle and specify that 7mm dimension. And now that the sketch is all black, we know that it's fully defined. We're not going to use this circle when we go to extrude this, but we will reference it later. And in fact, I'm going to do a little trick here to save me some time later on, and I'm going to drop a point on the quadrant of that circle. You'll see in a minute where we go ahead and use that. Now I'm going to go ahead and close this sketch, and I'm going to choose to extrude it. And because SOLIDWORKS doesn't give us a preview, you can also see by looking at its cursor, it's looking for contours for us to use. So I'm going to go ahead and choose the main contour here. And if we drag this out to the 70mm it's supposed to be, you can see that we get this arc from that circle. Well, this is the real beauty of contour selection. I can just select that circle and fill that in. Now, I did choose to extrude this 70mm, but it is a symmetric part, so it probably makes sense to maintain a midpoint relationship to keep all that geometry in the middle. That'll be especially important in just a minute here, as you'll see. So we've got this main body of our profile done. The next thing I want to do is I want to look at bringing in those sides out to that tangency. So a good place to do this, we're going to draw a sketch on our top plane. I'm going to draw a line from the vertex up here, and I'm going to bring it down, and I'm going to use this trick that's inside of SOLIDWORKS where, well, you're in the line tool. If you go back to the end point of a line, it'll actually snap and switch to an arc. And we'll draw another tangent line, and you can see I didn't get it quite in the center. That's okay. I'm just going to drop this here, and then we'll just drag that and snap that into place. Now, I know that this arc needs to be tangent to the end here, but I need to somehow calculate the diameter of this. Now, again, we could do a bunch of math, but what we're going to do is we're going to use that geometry we created in that first sketch. In the Feature Manager tree, you can click on any sketch and choose to show it. Once that's done, you'll notice now I can take the center point of this arc and holding my control key select the center point of this arc and make those coincident to one another. If you look at the top view, you can see that what we did is we captured the center point of that circle in that very first sketch and we're reusing it here. The next thing I'm going to do is I want to cut this out. Now you'll notice something unique about this sketch. It's not closed in any way. That's okay. SOLIDWORKS will allow you to use this. When you go to use an extruded cut with an open profile, SOLIDWORKS presents you with a few new options. One of them is this little arrow with the flipped side to cut. And if we change this to a through all end condition, what SOLIDWORKS is actually going to do is remove all the material on the outside of that sketch geometry. So we could have gone in and drawn the rest of that geometry, but there was no reason to. Now I'm going to reference that sketch again. This time we're going to draw the actual cut that goes through here, and you'll see how convenient that point we created is going to be. I'm actually going to snap from the center of the circle to that point we created on that vertex, and then all I need to do is go ahead and do a cut extrude. I'm going to switch the direction and change that to a through all end condition. Now I'm done with that sketch, so I can go ahead and hide it now. And that easily we've created the top half of our part. Now if we go back to the drawing, the next significant feature is going to be this pocket. And you'll notice it's a 7mm offset from all the surfaces around it. So let's go back here to the SOLIDWORKS part, and I'm going to show you two different ways you can tackle this. The first way is actually using some surface geometry. If I go up to my Surfaces tab on the Command Manager, we can create an offset surface of 7mm, and I'm going to offset this bottom face and this face here, and I'm going to choose to reverse their direction to the inside. Now, you might not be able to see those, but if you'll notice a new folder has appeared in the Feature Manager containing this new surface body. There you can get an outline of it. Let me show you how we're going to use this. I'm going to start a sketch on the top plane. And what we want to do is we want to offset several different pieces of geometry. Again, 7mm. So I'm going to offset that edge. Let's do that again to offset this edge, and then one more time to offset this circle here. Finally, I'm going to go ahead and clean this up by using Power Trim, and we're just going to get rid of some of that excess material. And in this case, we are going to close the sketch off. Now you're probably wondering, how are you going to use a sketch down here on the top surface to cut something up here? This is another great feature inside of SOLIDWORKS. When you cut, you can actually go in and choose to do the cut from an offset. Now, the diameter of this arc could change, so we're just going to set this way out there in space, like 100mm, and notice that the cut actually starts up here. And then for the end condition, we're going to change this to an up to surface cut condition, and I'm going to pick that right out of the graphics area there, and there we have it. We've gone ahead and created that cut. Now at this point, you could go ahead and you don't really need this surface anymore, so you can either choose to hide it, or I prefer, if I really don't need it, to just delete the surface out of the part altogether. We just needed that for some reference geometry. Now, the next thing we have to consider is all of this draft on this part. And I actually made a mistake intentionally here. The first piece of draft we're going to run into is along the outside of the part. This needs to draft 7mm in, and a neutral plane draft is a great way to accomplish this. I could pick this face or the top plane. I always like to use the system planes whenever possible. And we just select the faces that we want to draft. And when I right click, SOLIDWORKS drafts those in, but look what's happened. The offset of our material wasn't right in this case. This is actually very easily corrected. You'll notice if I go over to the Feature Manager tree, if the draft had happened before that cut, well, the cut would have been offset from the proper 7mm. So you can see it's really easy to quickly manipulate the Feature Manager tree to make different changes. There's no reason to go back and undo what we've already done. Now the second draft needs to start from here and go inwards. So how do we capture that? If we did a neutral plane draft from this surface, it would make this part way too thin. This is where parting line really comes in, and you heard me accidentally mention that. Parting line draft works in a similar manner in that you select a pull direction, but instead of faces, we're going to choose edges to draft from. Now I'm going to grab this edge, and you'll notice this arrow. That tells me it's going to draft this face. You can change that, but we don't want to draft that outside face. We want to keep that down. So let's go ahead and grab all these faces, and we'll make sure that those arrows are all going in the right direction. They're a little hard to see, but when I hit OK, SOLIDWORKS just reverses the draft. We didn't have to do the math and subtract 7 and then another 7. It just took care of it for us. And that's it. We've got that. The next thing we could do is add some fillets, but I want to go back. I mentioned there's a couple ways we could have created that pocket. I did this with some surfacing. I'm going to go ahead and delete this surface, and we're going to go ahead and get rid of several of these other features here. I'm not going to create a cut in this manner or this draft for that manner either. So here we've rolled back. We still have the draft on the outside of our part. Another way we could have tackled this, if we know that the wall thickness is always going to stay 7 millimeters, we could have used a shell feature, and by selecting this top face, it shells and hollows that out to that face. Now notice in this example, because of the order of the draft, these faces are tilted inwards. They're offset from that outside face. Well, that parting line draft actually works really well here, and that all we have to do is specify that draft angle, and SOLIDWORKS will fix that orientation automatically for us. Now you see how I got that error? That means that one of these edges is potentially going in the wrong way. My errors disappeared, so we're going to go ahead. There we go. See how these arrows are pointing to the outside? We need to correct that. So I'm going to grab those edges and make sure that those are both pointing down, and now when I press OK, we get the same results as before. So there you have it, 2 different ways to look at a very similar problem. Shell's probably the easiest, but it requires that all the offsets always remain 7. The other way we did it, we could change any one of them. Now, the next thing we want to do is there are some fillets on this part. If we go back to the drawing, you can see there's a bunch of fillets on that inside pocket. So if we come back here, how are we going to do this? Well, if you've watched any of the previous videos, you've probably seen that selecting faces provides a very powerful way to quickly grab a lot of edges. With 3 faces, I've grabbed all those edges that easily. Now, I could create the fillet that goes around the outside, but I do want to make sure that it blends to the second half. So let's get to look at mirroring this. So I'm going to go ahead and I'm going to choose the mirror feature. And for the mirror face, again, we're going to use that top plane. We've created everything off from it. And we're going to use the bodies to mirror option. And I'm going to grab the main body of this part and ensure that Merge Solids is checked and press OK. And there you have the part with the last thing we need to be those additional fillets. Now, I've talked about selecting faces. Here's an example where by selecting a face, we get a lot more than we're bargaining for. So here's an example where a face isn't necessarily a good choice, but maybe an edge will. And you'll notice that the tangent propagation follows all the way around to the part to about here. And that's because there's no tangency across that sharp vertex. So we'll just go ahead and grab that additional edge on the bottom, and you can see that it puts those together right there where they need to be. So we have our part done. Now here's where the real challenge comes in. We're given an additional drawing, and in normal model manias, you're tasked with changing several dimensions on the part. In this example, we've actually been tasked with creating several configurations of this part. And this is typical to what you would see in a parts or a supplier's ordering catalog. You'd see a table with several different dimensions that you could order the part in. So we want to be able to capture the same type of thing. So let's go into SOLIDWORKS and figure out the best way to do this. We're going to do this obviously using configurations, but there's a really clever way we can accomplish this using something called a design table. A design table is a great way inside of SOLIDWORKS to quickly build up a variety of configurations. And this can be accessed by going to Insert, Tables, Design Table. Now I'm going to go ahead and choose the Auto Create option because I want to kind of go through the process of selecting some information, and I'm going to simply press OK. SOLIDWORKS then launches Microsoft Excel into the graphics area, and it's asking us which dimensions do we want to include. Well, to be honest with you, these names don't mean a whole lot to me. So I'm going to go ahead and just hit OK at this point and kind of skip that process. What we want to do is we want to capture some very specific dimensions. So I'm going to just pick on this face, and you'll notice all the dimensions appear. This is because I have something called Instant 3D enabled. If we go back to the drawing, we can see that we need the large diameter hole, the distance between centers, and the angle of that slope. So let's go back to SOLIDWORKS. All I have to do is pick that diameter, the distance between centers, which we have in this first sketch, and the angle of the slope. That easily we were able to do this. And then we type in the other values. So we have 60, 125, and 10. Oops, I got a tab through this. 60, 125, and 10. 50, 150, and 7. And 40, 175, and 5. We do need to give these names as well. And the names are B, C, and D. Let's not let Microsoft Excel automatically fill this in. And this is the default configuration. It actually should have filled the name in here. We'll go ahead and just exit out of here. And you'll see that SOLIDWORKS will tell us that it's created these configurations automatically for us. So there we go. We've got the default configuration and configurations B, C, and D. Using that design table made that whole process quite easy for us to do. So there you have it. The design challenge from Model Mania 2002 with a unique twist where we're not making one change in phase 2, but instead we had to make 3 completely unique parts. I hope you enjoyed this, and if you have any questions or want to post your times, leave them in the comments below or use the hashtag SWW15.